Hello students, today we are going to learn the topic probability. Probability is a way to understand how likely something is to happen using numbers. It's like measuring how uncertain an event's outcome is. We use a scale from 0 to 1, where 0 means it can't happen at all, and 1 means it's certain to happen. You can also think of this scale as percentages, where 0% means impossible and 100% means certain. Now, let's dive deeper into what probability actually is. Probability is the chance that some event will happen. It is the ratio of the number of ways a certain event can occur to the number of possible outcomes. Some examples that use probability include dice, spinners, coins, deck of cards, evens or odds, and alphabet. The formula for probability is P of event is equal to the number of favorable outcomes divided by the number of possible outcomes. Next, this chart describes the various possibilities. 0% denotes impossible, 25% stands for not much likely, 50% stands for somewhat likely, 75% denotes equally likely, and 100% denotes certain. Let's move on to some important terms used in probability. An outcome is one possible result of a probability. The sample space is the list of possible outcomes for a probability event. Random refers to outcomes that occur at random if each outcome is equally likely to occur. A simple event is a specific outcome or type of outcome. Complementary events refer to one outcome happening and that outcome not happening. The sum of the probabilities of complementary events is 1. Now, let's look at an example of probability in everyday life. Imagine Best Buy is having an iPod giveaway. They put all the iPod shuffles in a bag. Customers may choose an iPod without looking at the color. Inside the bag, there are 4 orange, 5 blue, 6 green, and 5 pink iPods. If Maria chooses one iPod at random, what is the probability she will choose an orange iPod? The probability of choosing an orange iPod is calculated as follows. P iPods is equal to the number of orange iPods divided by the total number of iPods, which equals 4 divided by 20, resulting in 20%. Now let's consider another example, rolling a die. What is the probability of rolling an even number? The probability of the event is based on favorable outcomes, which are also known as possible outcomes. The number of favorable outcomes for even numbers is 3. Therefore, the probability of rolling an even number is 3 out of 6 or 0.5, which is 50%. Next, we can calculate the probability of each independent event. For example, P of black equals P of 1 equals P of odd equals P of prime equals. The answers are as follows. P of black equals 4 by 8. P of 1 equals 1 by 8. P of odd of equals 1 by 2. P of prime equals 1 by 2. Let's explore a real world example. A computer company manufactures 2,500 computers each day. An average of 100 of these computers are returned with defects. What is the probability that the computer you purchased is not defective? This is a complementary event. The probability of a computer being not defective is calculated as follows. P of not defective equals not defective divided by total manufactured, which equals 2,400 divided by 2,500, giving us 0.96. Next, let's differentiate between experimental and theoretical probability. Experimental probability is defined as the number of times an event occurs divided by the total number of trials. Theoretical probability, on the other hand, is the number of favorable outcomes divided by the total number of possible outcomes. For example, in an experiment where we flip a coin, we might find that P of Pz equals 3 by 10, as a head shows up 3 times out of 10 trials, while P of P equals 7 by 10, since a tail shows up 7 times out of 10 trials. When we look at theoretical probability, P of head equals 1 by 2 and P of tail equals 1 by 2, since there are only 2 outcomes. Thus, you have a 50 to 50 chance to get a head or a tail. Let's discuss the sample space next. A sample space is a collection or a set of all the possible outcomes of a random experiment. For instance, the sample space of all outcomes when two dice are tossed together includes outcomes like 1-1, 1-2, 1-3, and so on until 6-6 on both dice. Now, we will look at an exciting example, the probability of getting a sum of 7 when two dice are rolled. First, we must calculate the number of events in the sample space. From our previous slide, we know that there are 36 possible sums that can occur when two dice are rolled. Of these 36 possibilities, how many ways can a sum of 7 occur? We can obtain a sum of 7 with the outcomes 1, 6, 6, 1, 2, 5, 5, 2, 4, 3, and 3, 4. It is important to note that there are 6 ways to obtain a sum of 7. The outcome 1, 6 is different from 6, 1 in that 1, 6 means a 1 on the first die and a 6 on the second die, while a 6, 1 outcome represents a 6 on the first die and 1 on the second die. Now, let's go over some properties of probability. The first property states that the probability of any event will always be a decimal or fraction that is between 0 and 1, inclusive. If P of E is 0, we say that event E is an impossible event. If P of E equals 1, we call event E a certain event. Some have said that there are two certainties in life: death and taxes. The second property states that the sum of all the individual probabilities of each event of the sample space must equal 1. For example, if you flip a coin, the sample space is S, which consists of head and tail. Therefore, P of P plus P of tail equals 1 by 2 plus 1 by 2, which equals 1. In conclusion, we have learned that probability helps us understand how likely events are to occur. We explored various examples and terms, distinguishing between experimental and theoretical probabilities and understanding the sample space. Probability plays an essential role in our everyday lives and decision making. We hope that you have understood the topic. You can now study chapter notes, watch video lectures, and solve MCQ tests of this chapter on EduRev to ensure you score well in your school exams. And that's not all. You also get amazing courses for maths, science, English, Hindi, and much more for class 10. Thank you.